this is Captain Chaudhari. In my series of videos on marine astronomical navigation, today I'm going to talk about the relative motion, particularly the daily relative motion, which happens because of the spin of the Earth. Right? As the Earth spins from west to east, we find that all heavenly bodies, they appear to go from east to west. So this is the relative motion that we see. In other words, we say that all these heavenly bodies, they have a tendency to change the meridians which we talk about in equinoctial system, the celestial meridian. Because with respect to sun, the Earth completes a rotation in 24 hours, right? So we say that 360 degrees divided by 24, that is 15 degrees, sun changes the meridian at the rate of 15 degrees per hour. Similarly, we say that the Aries or stars, they change meridian at the rate of 15 degrees 2.46 minutes or 15.041 degrees. This is because a sidereal day is of 23 hours 56 minutes 4.1 seconds. So if we divide 360 degrees by 2356 4.1, we will get a rate of 15.041 degrees. Moon changes the meridian at the rate of 14 degrees 19 minutes plus V per hour. It normally would not fall below 14 degrees 19 minutes. This fluctuation is because of the close vicinity of moon and also perigee and apogee. Perigee means when the moon is closest to the earth, and apogee means when the moon is furthest from the earth. So rate of change of meridian for the moon, it is 14 degrees 19 minutes plus V. V is the difference of rate compared to the basic rate 14 degrees 19 minutes, on the basis of which the increment tables in almanac. So suppose V for the moon for a particular hour is say 13 minutes, then we say that the actual rate of change of meridian by the moon is 14 degrees 19 minutes plus 13. So that is 14 degrees 32 minutes. So if somebody says GHA at 1700 GMT is 215 degrees for the moon, 00 minutes. So at 1800 hours GMT, it is going to be 215 degrees plus 14 degrees 32 minutes, because the V for that hour is 13 minutes, and V in case of moon is always positive. So GHA at 1800 will be 32 minutes plus 229 degrees 32 minutes. So this is how with the help of V, we come to know what is the actual rate at which the moon is moving. So V correction is a concept which is specific to the almanac, the way the increment tables are made in the almanac. Like the increment table for sun are made at the rate of 15 degrees per hour. That means in 30 minutes, the change of meridian by the sun will be half of 15 degrees, that is 7 degrees 30 minutes. Whereas the increment tables which are made for moon, it assumes that the moon moves at 14 degrees 19 minutes, and if, say for example, I want to know how much will the moon change the meridian in 30 minutes, it will be 7 degrees and 9.5 minutes. Right? So the tables are made on the rate that is 14 degrees 19 minutes. The reason that it is made on this least rate, that is 14 degrees 19 minutes, is because whenever we need to apply V correction is always positive. As I told you, the V correction is a concept which is related to the almanac, the tabulation in the almanac. Now, because the rate of change of meridian by the planets is very, very close to 15 degrees, which is the rate of change of meridian by sun. So what they have done is they have included the increment table of planets along with the sun, because a planet might be moving at 15 degrees 2 minutes per hour or 15 degrees 2.5 minutes per hour, or in case of Venus sometimes it is 14 degrees 59 minutes or 59.5 is sometimes positive and sometimes negative. Otherwise, in case of the moon or planets, generally the V correction is always positive. Only in case of Venus it may be sometimes negative. So what is this V correction in case of planets? Let us understand. If V for Jupiter is say 1.5 minutes, then we say that rate of change of meridian by Jupiter is equal to 15 degrees plus 1.5 minutes. Right? That means in 2 hours the change is equal to 30 degrees and 3 minutes. So this is what is V correction for the planets, right? And because the rate is very close to 15 degrees, the tabulation of increment is done along with the sun, that is at the rate of 15 degrees per hour. Sometimes this concept can be better understood with simple numerical. Let us say on a particular day, if the average value of V for moon was say 12 minutes, then we say that for that particular day the rate of change of meridian by moon is equal to 14 degrees 19 minutes plus 12 minutes, that is 14 degrees 31 minutes, right? So the length of lunar day will be 360 degrees divided by 14 degrees 31 minutes, which is explained like this. Suppose this is the Earth we see from North Pole. Here is an observer, right? If he finds the moon on meridian at a certain time and then he goes around the Earth, by the time he comes back here he finds no moon and moon has advanced in its orbit, and he finds the moon after some time, that is after the lapse of 24 hours. So what is that duration can be found out this way in case we know the average V for the day. So let us say so it is 360 degrees divided by 14 degrees and 31 minutes. That gives me 24, 47, 56. So it is 24 hours, 47 minutes and 57 seconds. So this is the length of lunar day, and length of lunar day is more, as you know, because the moon advances eastwards in its orbit, so the duration is more than the solar day or sidereal day. Generally it is stated that why there is no V correction in case of Sun and Aries. Aries because the distance is very far. Like Aries or stars, they are very far from the Earth planet. That's why the rate is steady, and we can say it is 15 degrees 2.46 minutes or 15 degrees 2.5 minutes. Like in case of Sun, except for aphelion and perihelion, there is no reason why the rate should change so much. So it's reasonably constant as far as the solar day is concerned. Solar day usually is almost 24 hours. So rate throughout is 15 degrees per hour. So in case of Sun, we have no problem. We don't have to maintain the V. Like in case of planet, we maintain V because the rate is not precisely 15 degrees and we want to tabulate the planet's increment tables along with the Sun. It may be slightly different than 15 degrees, so that fluctuation is taken into account. Even if the rate of change of meridian by a certain planet is reasonably steady, but it is not exactly 15 degrees. The tables of increment are made for 15 degrees, so the planets can be accommodated along with the Sun. So in general, we can say that we have no V correction for Sun and Aries. For planets, we have V correction. For Moon, we have V correction. It is always positive, except in case of Venus, where the rate can be sometimes negative. Now this is the celestial sphere. As seen from top, this is North Celestial Pole. And we say that, imagine that Earth is over here and we can see the Earth meridian and there are celestial meridian. Suppose this is the meridian of Sun and this is the meridian of Aries. This is some star and maybe this is Moon, and there might be meridians of planets. So if we consider the meridian of first point of Aries and we measure this angle is called SHA of the Sun, because this is a westward or clockwise angle from first point of Aries to the Sun. This is SHA of the Sun. It's a very well known fact that SHA of the Sun always decreases, and the rate of decrease is 2.46 minutes per hour. So if the Sun is moving at 15 degrees and Aries is moving at 15 degrees 2.46 minutes, that means the Aries is always in the process of overtaking the Sun. Even if Aries has overtaken the Sun, right, it again starts overtaking, so that when after some passage of time, Aries is going to overtake the Sun once again. So there is always this process on, and this is called reduction of SHA of the Sun, which is a universal phenomenon. SHA of Sun always reduces at the rate of 2.46 minutes per hour. Now, if we say that the Moon moves at 14 degrees 19 minutes plus V, which we just studied, it means that there is always a tendency of Sun to overtake the Moon, right? So Sun is going to very soon, after a couple of turns, probably the Sun is going to be ahead of Moon, and that process continues. It's a universal process because the rate of change of meridian by Moon will never be more than 15 degrees. It's always less than 15 degrees. Okay. Now, a question could be asked, like if the SHA of the Sun presently is, I'm just saying 22 degrees. SHA of 22 degrees at 1500 GMT. Can you tell me what is the Sun's SHA at 1800 GMT? Now SHA, as you know, is a westerly angle from first point of Aries to the Sun. Now we are talking about the reduction of SHA, therefore, in 3 hours from 1500 to 1800. Now the rate of change of SHA, that means reduction of SHA, is 2.46 minutes per hour. So in 3 hours it is 7.38 minutes, that is the reduction. So from the present SHA, which is 22 degrees, it will be down by 7.38 minutes, so it will be 21 degrees 52.62. So 21 degrees 52.62 will be the SHA after 3 hours. One interesting question could be, like on this North Celestial polar diagram, suppose we find that Aries and Sun are together. Naturally, the Aries is in the process of overtaking the Sun, right? So Aries is seen overtaking the Sun. After how long Aries will again overtake the Sun? How much time it will take for the Aries to overtake the Sun for the second time? So the answer is, Aries overtakes at the rate of 2.46 minutes per hour. So once the Aries has passed the Sun, Aries will have to overtake the entire 360 degrees. So we may say 2.46 minutes is overtaken in 1 hour. So 360 degrees into 60 minutes will be overtaken in how many hours? So it will be 360 into 60 divided by 2.46 hours, or if you divide by 24, it will be so many days. Let us see how many days it is. 360 into 60 equals divide by 2.46. I get 365.85. 365.85. Oh, this means that it will take nearly 1 year. So although this is a polar diagram, although we are talking about the daily apparent motion of heavenly bodies, but there is an opportunity for Aries to overtake Sun, and incidentally, let me tell you, incidentally, this particular phenomenon that you see this happens on say 21st March. If I ask you the same question in another diagram of celestial sphere whereby this is equinoctial and this is ecliptic, and if I say this is first point of Aries and Sun, as you know, moves from west to east and Sun is over here, you feel that yes, Aries is fixed and the Sun is moving. And when Sun completes one full round of the celestial sphere and comes back to this position, naturally it is going to take 365.25 days, 1 year. Okay, so the same thing explained here, but here we are looking at the daily apparent motion, and here we are looking at the annual motion of the Sun on the ecliptic. So suppose we look at the polar diagram with north celestial pole here, and we see various heavenly bodies. For example, Sun is over here, and then Moon is over here. You might have some planets over here, and you have first point of Aries, and then you have stars over here. So on a daily basis, in 24 hours, the Sun will come back to the same position, right? And the Aries will come slightly forward of this position, because Aries moves at 15.041 degrees per hour. And same is the story about the star. Planet will slightly be forward of it, except Venus. Planet and Sun distance will also slightly decrease. And as we have seen in the previous example, Moon might be moving at 14 degrees, say 25 minutes, whereas the Sun moves at 15 degrees per hour. Relatively, because of the spin of the Earth, because of the daily relative motion, the gap is going to reduce between the Sun and after several hours or several days, if we will find that Sun is in a way overtaking the Moon, and the gap between the Aries and Sun reduced, whereas the gap between star and Aries remains nearly constant. So this is what is the relative motion of heavenly bodies because of the spin of the Earth.